So proactive maintenance, what can we do? Okay. Prevention over the cure. Find out what you can prevent it. Not only a one-time fix, but what caused it. I go back to the forensics. What's the root cause? Okay. Direct FM staff to identify the problem areas. Okay. Have them report these particular areas, such as, the air handlers at the end of the facility seem to have a higher level of dust and dirt concentration than the air handlers in the front of the building. Why is that? Well, because in the back of the building is where we have a lot of our landscaping. Or maybe there's some community, maybe we're next to a farm. Okay. My building, when it was built in 1954, behind me to the south was basically a large field. It was, it used to be dairy land, right, alfalfa fields. So when we built the air handlers, when we installed the air handlers, all the fresh air came in from the south. Well, that's reasonable, right? So that was in 54. Fast forward to, say, 84. That big open alfalfa field is now a big parking lot, right? So that parking lot heats up all day long in the middle of July. So what happens at night? So that air temperature coming in off the south. Remember, it used to be alfalfa fields. We didn't have to worry about that. So now, fast forward, my temperatures are typically 10 degrees higher on the south side of my facility than they are on the north side. So that means I've got to cool that air at 11 o'clock at night by 10 degrees to bring in that air. So it's an energy, right? So people ask about the heat idle effect. It's real, okay, and it's true. And I got a facility to prove it, okay? Again, employees' health and safety is going to be the biggest concerns, and it should be your priority. And then everyone benefits, okay, with a good indoor air quality program, okay? So proactive inspections and samplings, that is inspecting, analyzing systems, okay? Building construction, building operations, they should be integrated. Testing your data and samples in order to produce an objective and comprehensive report. And again, this is intended to identify and correct problems. If it's temperature, if it's particulates, okay, maybe it's distribution. That's where you want to manage an indoor air quality program. So you prevent those. That's going to say this prevention versus the cure. The cure is a one-time shot. I want to prevent it so I don't have to react to the cures. Okay. Now here's my facility. Here's one example here. So this is my Roosevelt facility, right? And I have a CMMS system, and I started to record my hot and cold calls at my facility. Gosh, and this is back in '94. This is pretty dated, right? But what's interesting about this, we never used a computerized maintenance management program, ever. So when we introduced it, started collecting data, we said, you know what? Let's find out hot and cold calls that average above 5 a month. Okay, if I got a hot call more than 5 a month or a cold call more than 5 a month, right? So we'll start that as a baseline. So what we've discovered is the blue, what do you think the blue signifies? What type of calls? Oh, you guys are good, right? And of course the red is hot calls, right? Now here's a phenomenon. This is about 80,000 square feet, right? Complete floor. There's a large air handler. That's those big air handlers I was telling you about, the size of this room. So I got one big large air handler sitting right there, right? And I have a single zone, right? That goes out into this facility. If I have a single unit, right? How could I have hot and cold calls coming off a single unit? What's up with that? Okay, and we use that theory. I says, okay. I says, so I got my coldest air, my greatest volume coming out here, but why aren't these areas blue then? Right? So then we thought heat load. It's got to be something with heat load. Maybe I've got more manufacturing equipment in here than over here. Went through, same amount of equipment. We ran tests on all the electrical panels, same amount of power, right? So then, again, going back to what the prevention versus the cure, started to look at above the ceiling. Okay, the ducts were okay. The controls. This was an old pneumatic system that was installed in '84. Okay, pneumatic systems, you may see those in your tour. They use low pressure air, compressed air. And they use that air for air actuators or air actuated valves for dampers and valves, right? So this is what we found out when we went through and did the diagnostics for this particular one. Then we applied it to the rest of the facility. Low pressure air runs through plastic tubing. When you're above the attic and you're looking at tubing, it mixes in with what other cable that I've got up there? Computer cable, right? It's the same size, same diameter. So when the electricians and my IT folks were up there working, they would cut the tubing. Which means if I have no air to actuate a valve, what happens? I have no control, right? But something happens when you cut that tube. What do you think happens? I got 15 pounds of air, and to cut that tube, did something come out of that tube? Noise, air, right?
And they didn't tell anybody?
Didn't tell anybody. But they plugged it with a piece of tape or a screw or something, whatever fit in the hole, right? And it says, you know what? I don't know what this is, but it's not leaking water. So if we plug it, it should be good, right? So when we went through, we done a diagnostic, we found valves, one, that had no air, no low pressure air. Other items we found is that they had actually failed over use and time, because once they went in above the drop ceiling, it was done. We'll never go back up there again unless we do a remodel. But this particular one, with the cycles go on and off, especially manufacturing facility, it basically wore out the linkages. It wore out the damper blades just with the wear and tear. So now we have a PM where we go through twice a year and we inspect above the ceiling just to catch those. So these calls, as you can probably, I still have a few, but it's not to the point that it is here. Okay, but again, it's just some forensics, right? Okay, trying to find a prevention versus just a cure. If we just did the cure, right, I'd still have them spring up in other parts of the facility over time. So let's find out what the root cause is on that particular one, right? And then understanding threats to indoor air quality. Again, you got outside threats, right? So this is any pollutants that you got on the outside of your facility, outside of your building. Now, new construction, architect comes in. Where do they usually put the return air and a dumpster? They're like magnets, right? Opposites. What do you think? I'll let you guess. I got my garbage bins. It's wet trash. It's right by the cafeteria. Nobody wants to see the ugly vents in the front of the building, because this is what? This is going to be one of those showcase buildings. So let's put all the stuff in the back. So here it is, your return air vent, or it's right next to what? The grill. I mean, it's good enticing for the food, right? So hamburgers or fish, right? Good, it's Fish Friday. I'm hungry. I can smell it, right? Okay. But again, those are some of the items, part of new construction. You look at those. You look at what's going to be the issues and problems that's going to create from the exterior side. Other items are loading docks, okay? Diesel gets carried in through the outside air. A lot of folks say, but your filtration system should take a lot of those smells out. You can't. Okay, the smells permeate through the filtration systems unless you got carbon filters, okay? But who would have guessed to put carbon filters till after the fact? It's a change order, right? And then internally, I go back to the HVAC equipment, okay? Our process and how we execute, the buildings, the people themselves, okay? Components, we covered those. All those equate to the level of indoor air quality you're going to have. So again, you got to tie both of those together, exterior-wise and also interior-wise, okay? So I look at this room here, that door is kind of closed, but you open that door and you're right into the dock, right? I mean, could you imagine if you had like 4 or 5 cars idling out there and somebody was sitting there with a door open, right, and letting all those fumes in? And then I look at that door over there, right, and I see a parking lot. Imagine if someone had that door open, right, and these doors were open. So what I've got, I got return air. So all that air is now coming out because I opened up the doors and outside air, right? So what did I do? My balancing was disrupted. So now I'm pulling all that air up through my return air and where? Back into the room, right? Same thing with dust storms and so on that may happen, okay? So ways that indoor air quality may be measured. Again, direct with measuring devices. You've got wands. Okay, you've got particulate counters. Okay, sampling. Okay, air and sending samples to labs for analysis. Number of spores. How do I react to it? What type of chemicals or biocides do I need to use? You can identify that information coming back from the lab reports. Okay, indirectly by gathering statistics related to the occupant health and productivity. Calls, the hot and cold calls that I shared before. Okay, subjectivity by survey. Okay, making sure who you surveyed and when and what time of the year. Okay, that's going to play a critical part. Okay, and then measuring indoor air quality. Primarily, it's the fresh air rate, right? Cubic meters per second. And fresh air per person, typically, what is the ASHRAE rating? It's like 15 CFM, 20 CFM per person fresh air. Right? In some cases, it's up to 75 depending, right? And then you multiply that by the number of occupants. That's going to measure the amount of outside air that you need to introduce into your building. Very simple equations. But again, it's a real quick what acid test. Am I introducing sufficient amount of outside air? Now, you may get an equation like this on your exam. Not this exam, but the next exam, second exam, okay? So I'll come back and review to make sure, okay? And avoidance procedures, as we talked about before. Ductwork, different type of stages of ductwork. If you ever looked at the evolution of ductwork construction, what did we have? I mean, go back into time. Paper, cloth. You ever see the tube ductwork? It's a big tube. They got all kinds of names, but they typically call it tube ductwork, right? I won't go there, right? Okay? He knows where I'm coming from. But again, what this is, it's collapsible ductwork. You turn on the air conditioning unit, okay? It pressurizes the ductwork. It goes back up into where it should be, right back into position, and it distributes air. You turn it off, it cycles back down, and it deflates like a big balloon, right? Then you had what they called fiberboard ductboard. Okay? That was back in the 70s. Okay? And, you know, that one there basically came in sheets. And you could build ductwork. I mean, you cut it with a razor blade. You folded it over because it had seams in it, right? And then you put a piece of, typically a foil tape. That's what kept the seam together, kept it from collapsing. And then you took this up and you stacked them together. And then you go ahead and put another tape seam, foil seam around it, right? And then you suspend it. It was cheap, inexpensive, easy to put in, right? Anybody could do it. I didn't have to use expensive metals, didn't have to insulate the metals. But the interior of that ductwork, over time, what did it do? It collected dust and particles. Other items is insulated the interior ducts. I still don't understand why they did that. They insulated the interior of the cabinets. So it's regular, right, permeable type of insulation materials. So over time, that just coagulates dirt and dust and moisture and fungi and molds and spores and everything else. So it's not a very good system. So now what you can do is actually line it with Mylar. Okay, Mylar, one, resists the exposures to the different types of bacteria and spores. But not only that, but it's smooth. So it keeps that coefficient, because you're coming across that, to keep those contaminants flowing and minimize them sticking to that particular ductwork. Ductwork tested for leaks and blockages. Okay? When you pop your head above a ceiling tile and it's cooler up there than it is down in the room, you probably have some leakage, right? Okay. Exhaust inspected and cleaned on a regular basis. Filters cleaned. Okay. Areas subject to leaks and inspect regularly. So if I have water leaks, drywall especially, okay. You know, sometimes it's not a big deal. It gets wet once, maybe twice. But if it gets saturated on a regular basis, you can tell that it starts to degrade. And then the paper. All it takes for paper for molds to grow is some sort of water source, and I'll call it food source. In this case here, it's going to be minerals and dust particulates. That's what causes mold to grow, right? So again, in some of those cases, you know, you can bleach it and so on, but what does the bleach do? You got to evacuate everybody out while you treat it. The best item is to cut the drywall out, but then that gets expensive because now you go back to the drywall and the paint and everything else, right? Okay. Some operational initiatives. Okay, use demand control ventilation. Use it only when you require it, such as an auditorium. If it's empty, I'm cycling it way down. I'm not using outside air or introducing additional cooling or heating. But I start to fill it up, it makes the adjustments, so demand control. Okay. Higher efficiency air filters, depending on the application. Ultraviolet lights near air conditioning. Okay. Again, it's burning off the different types of molds and spores, okay, being introduced into that particular air distribution system. Review how space is being used and organized. In some cases here, it's not really never intended for individuals to reside in. So the entire infrastructure, HVAC infrastructure, needs to be upgraded in those particular ones or replaced. Okay. Adjust an overnight purge, okay, facility air. Again, I go back to the economy dampers, economy cycles. Okay, being able to use that to purge in. But in some cases, you'll do it purposely. Okay, and again, then ask to purge that particular building. In some cases, you may not, but depending on the application. So a movie theater, perhaps after you show the last movie, you may run your cycles and purge that theater maybe for the next 2 hours, as you're cleaning and stirring everything up. So you're running the cycles through that. So by the time they're done cleaning, it goes back down into your regular cycle, and it's ready for the next go around, for the next day. Okay. Implement a policy of reviewing materials, right, and furnishings for the pollutant emitting potential. So again, formaldehydes, we had talked about different types of bonding agents, okay, waxes and cleansers. Pledge, everybody loves pledge, but it's a contaminant. Okay, and it's not an item where you just spray a little bit. Do we ever spray a little bit when it comes to that? We spray a lot, don't we? Because again, we want it extra clean, right? So we're going to put more. More is better, right? Okay. Conduct periodic audits for indoor air quality threats, again, internally and externally. Okay. Gaskets around this door. Does this door have the gaskets? Are they in good shape? It has no gaskets. It's an old building, right? Okay, come on. Here's another cell, too, is the adjustment on the door, too. If it had a gasket, it wouldn't do that, right? So you'd seal the air. But, again, I'm not complaining, right? Okay. And then ensure that risk management plans are developed from the event that you do get contaminants. Remember the anthrax threats that we were having? Okay. On how do you do emergency shutdown so you don't spread, right, the different types of hazards and risks throughout the rest of the building. Okay. So again, you're going to look at those particular ones. Okay. What is going to be considered a risk to the facility? Okay. And then on water systems, this is the other side, and not only air, but now you got water systems, cooling towers. This particular one is scale forming on a cooling tower itself. When you go through the central plants, you're going to see two different types of cooling towers. Okay. The one cooling tower is you're probably going to see a water, okay, fed that are chemically treated. Okay. The other type of cooling may be considered air, where they're actually cooling with air through a fan. Okay. Look at the type of particulars between the two applications. Water is more convenient and probably more cost effective than it is air. Right, because they're not pushing air through coils, using fan and more power. However, water in this case here is going to require some sort of water treatment program. I can't just run regular garden hose water through these particular ones, again, because of contaminants. Right? So microbial analysis of select water sources is going to be condensate pans, and what I'm doing, I'm measuring to the level of what? Particulates and pollutants, right? Any type of risk. Humidifier reservoirs, especially if they've been idle for all year. I've had water sitting in there since, say, February when I shut them down. So, typically I'm going to go through and drain them and purge them and then fill them up again with distilled water before I start my next humidification cycle. Just standard PM, right, to minimize that. Okay. Cooling towers, and of course coils from within the building and your air handlers. Legionella bacteria. Remember that? It was called, they had a name for that. Remember that where it killed... the Legionnaire's disease. Remember that? Okay.
That's because it was a convention.
Yep. Okay. Yeah, the American Legion actually, this convention, and that's what they called it. That particular one there. But that particular one, though, they traced it back to cooling towers. Okay. And again, the cooling towers were what coming in through the outside air, being introduced into the vents, and then of course that picked it up within the air handler and spread it throughout the rest of the building. Now, that didn't affect everybody, but everybody's respiratory health is different from your person sitting right next to you. Everybody's different. Okay. You're going to also look for total microbial counts. What's your saturation levels? Okay. Water treatment processes and quality. You get what you pay for. And some of the water treatment, and we'll cover this next week, but I got one slide I'll go through you real quick. It's just as important to treat the external water as it is the internal water. I'm going to show you in a minute here. Okay. Biocides in regards to that water, anti-foaming agents. I know if you ever walk by a cooling tower and you see all the foam coming out of it, it looks like soap. And again, they've got the chemicals in balance in that particular cooling tower. It's not there just for the bubbles. Okay, so you use anti-foaming agents, so you introduce another chemical. But now you've got several chemicals working against one another. So this is why they consider the blowdowns in a cooling tower. Blowdowns is where you're taking a lot of what they consider the total dissolved solids, TDS levels. And again, in Arizona, we have a lot of minerals. So in that particular one, I'm going to have blowdown. So I'm going to introduce fresh water in my cooling tower sump. After 2 or 3 cycles of water, I'm going to discharge Say it's a 200-gallon cooling tower. I'm going to discharge 100 every third cycle and introduce another 100 gallons of fresh water. That water typically will go into the drain unless you have some sort of reclamation unit where you filter the water and reintroduce it back into the sump, right? Okay. But without doing that, what happens is I get this. I get a high level of scaling. If I don't want to do that, I need to introduce more chemicals. In some cases, it's sulfuric acid that it keeps those agents from bonding together, right? So I can filtrate them. I got sand filters on my cooling towers that require maintenance. So it's a whole different process. But this is all the water that catches the outside atmosphere, which is what? Full of pollutants, right? Okay. So we'll cover those. I got a slide coming up for that. Neutralizers. When I got to 2 that are in balance, I'll introduce neutralizers. And then I've got sensors that sense, and they tell me when I do have imbalances in chemicals. Okay. So here's an example here. The blue, this is a chiller, refrigeration chiller, right? The blue here is my chill water. And this box here is my air handler. So on one side of my chiller, right, I got my inlet. Actually, it's here. This is my inlet, my chill water pump. So it's low temperature. Say I'm pumping out cold water, say at 57 degrees. I'm introducing it to the coil. It's got a fan. It's running it past the coils. I'm cooling the room, right? And then I got my return, okay, chill water. And say it's coming back at 68 degrees. So what it did, it transferred the heat from the room into the coils. Okay, the water heated up. I send it back around. It's a circuit. This is a closed water circuit, by the way. Okay, and again, I use my refrigeration through compressors and refrigerants to cool that water back down. Okay, so I got a 2-stage system. The green area is what I consider my condensate water. So the condensate water is extracting the heat that I've taken out of my chill water that's been extracted by the refrigerant. So now I got to pull the heat out of the. It's a real complicated system, isn't it? Right? So now I'm pulling the heat out of my refrigerant through my condenser water. Well, since this water is introduced to the outside with my cooling tower, so I introduce this here. This is my inlet. So my inlet comes up here, and what I call troughs. So it comes into a trough, and the water basically it cascades down to medium. Then I got a large fan on top of the cooling tower, and it's blowing air up. So I got air that comes in through here. It vaporizes, or it actually drops the temperature in the water. It's like an old evaporative cooler, right? Have you ever noticed these, the APS power generation facility here? When it's cold outside and you got a low dew point, you see the big plumes, right? Well, a lot of folks say, oh, those are pretty. Well, actually, that's heat that's being extracted. So they're running a lot of power, and you see every one of those setting up a plume. Typically, you only see small plumes. So when I drive up to my facility, I don't want to see big plumes. I want to see just a little plume. That tells me that I'm only extracting a minimum amount of heat into the atmosphere for my building. Okay, so everything's balanced and adjusted. So that cascades down, goes back into my suction pump, starts to process all over. So these are 2 split systems. Okay. Now, this is the water treatment side. So this is going to be considered maintenance. Now, since I'm using acid, some of it's very corrosive, such as acid or sulfuric acid, too much of it will actually etch my tubes. Inside of this unit, I've got tubes that run through that, and water saturates the tubes. And I got refrigerant on one side, it cascades down and it separates the heat. And on the other side, I've got cooling tower, water that saturates that as well. Okay? Too much sulfuric acid will actually etch the copper. And then what will happen is I'll have a failure inside the chiller, which now means a catastrophic. So I lose all my refrigerant, which is not good, right? And I got a major failure in my system. So that's why water treatment is so critical. The only thing to remember, water treatment is extremely important because of the infrastructure and the components, the damage. I'm not going to ask you how it operates. I'm just going to ask you why water treatment systems are incredibly important, okay, in regards to a cooling system, okay? And then typically this is a 2-pipe. So 2 pipes either in the summertime are running chill water, or possibly in the wintertime I'm running hot water. I'm using the same pipe, but I'm using two different types of medium. Okay. Then this is a typical rooftop unit. Okay, and there's all the components that tie in with it. So very much like this room we're sitting in here now. So up at the air handler, I'm going to have a supply fan, supply air. Okay. It's going to come into a duct distribution system, so with the supply air diffusers like I've got now. I'm going to have a damper in this particular air handler that's going to let not only return air, but outside air as well. Okay? And I'm going to have an exhaust vent so that I don't overpressurize and it blows the doors open. So those are going to be the adjustments to balancing, right? I'm going to have a fan. This is my hot and cold coils. Okay, so in the wintertime, my hot water coil will probably be functioning unless I want to dehumidify. And this is my chill water coil or cold water coil. Okay, I may have an exhaust fan within the room, so if I overpressurize, maybe it's a weekend, nobody's here, so I'm going to use an exhaust fan to bring down that pressure in this particular room in some cases, right? Return airs. But if you consider every one of these components in this little diagram, it's going to require maintenance. Regular inspections, right, on how well the systems are operating and functioning, okay? So you may get possibly some questions on a typical air handling system, such as, what does a cooling coil do? Okay, what's an exhaust fan requirements for? Okay. And this one here is that variable air volume system I was talking about before. This is a constant fan. I'm blowing the same amount of air at the same temperature through all these offices. All I'm doing at the thermostat is I'm just adjusting the damper. So if I want it warmer, I adjust the temperature up and it shuts down that damper. If I'm too hot, then I'll again put it down into the cooling cycle and it opens up that damper. Okay, very simple, very simple. But again, every one of these components is going to require, here's my 3 wave valves, okay, my hot cold coils, this is actually my air handler, my return air fan. Okay, but every one of those inspections for indoor air quality, depending on what's the condition of the systems and components. Okay.